Hey everyone, in this video we're going to be looking at the big ideas for section 8.2. And in this section we are looking at creating a confidence interval for the difference between two proportions. So we're still going to follow this plan. We're going to state our parameter of interest and our confidence level. We're going to name the procedure underneath our plan. We're going to check our assumptions and conditions, which we'll show right here. We're going to do the work, and then we're going to draw our conclusion. So all of this follows the same pattern as what we saw for creating a confidence interval for one proportion. But there are a few things that change just a little bit. So when we state our parameter, what we're looking at is the difference between two proportions. So we need to use this symbology. We need to say P1 minus P2, or if you change the subscript, that's okay too. And this means the true difference in whatever those proportions are. When it comes to the plan, the procedure that we're looking at is no longer a one proportion confidence interval. It is this. It is a two sample Z interval for P sub 1 minus P sub 2. So we have two samples. It's a Z interval because we're going to use a Z score for our critical value. And what is this for? It's for the difference between two proportions. So this is the name of the procedure that we're going to use. Then we check our assumptions and conditions. Now, slightly different situation for our conditions here. We want to look and name that these two samples are not only random samples, but they are independent random samples. The two samples that we end up getting and collecting to estimate the difference between these proportions need to be independent random samples. So we need to make note of that in this particular condition. The 10% condition still holds, but we have to check the 10% condition for each sample individually. Same thing with the large counts condition. We want to check n times p hat and n times 1 minus p hat, but we have to do that for both samples, and we have to show that each one of those four calculations is greater than or equal to 10 in order to satisfy the large counts condition. When we get to the do, we're going to write our generalized formula, we're going to write our specific formula, and then show the work. Well, the specific formula looks like this. You've got your point estimate right here, p sub 1, p hat sub 1 minus p hat sub 2, plus or minus your critical value times the standard error. And remember, this is standard error and not standard deviation because we are using p hat sub 1 and p hat sub 2 in these spots instead of p. And then you've also got your first sample size and your second sample size. So all of this together is your standard error. And then our conclusion is the same as it's always been. We are blank % confident that the interval from blank to blank captures the true difference in proportion between whatever your context is. Now, there's one more thing we want to look at when it comes to this type of confidence interval. And we want to talk about convincing evidence. Do we have, does the confidence interval give us convincing evidence of some things? Well, what does it convince us of? Well, there's three situations that we have. The first one looks like this. If both of your values in your interval are positive, that means that your first proportion is greater than your second proportion. So you gotta, and you have to be very cognizant of the order of this, okay? Maybe you're comparing males to females. Maybe you're comparing juniors to seniors. Maybe you are comparing teenagers to adults, whatever it may be. But the order matters, okay? It gives you context, so you got to pay attention to that. So if both of your values in your confidence interval are positive, that means that the proportion that you listed first is greater than the proportion that you listed second. Well, if both of the values in your confidence interval are negative, that means that the second proportion is greater than the first proportion. And then finally, if you have one of your values that is negative and one of your values is positive, then what we would say is that there is no convincing evidence of a difference between the two proportions. And that's because the interval contains 0. Remember that the confidence interval is a list of all the plausible values for your parameter. If our parameter is the difference between two proportions, if 0 is contained in your interval because you've got one negative value and one positive value, that means that we do not have evidence that there is a significant difference between these two proportions. And that's because one of the plausible values in our confidence interval is 0, which means that there would be no difference. So there's all of the big ideas for section 8.2. Hopefully this helps you understand a little bit better, and hopefully you have a great day.